Hi, Gadget UK here again. This time another quick board build video, but mainly testing. We'll get onto the testing part of this. I think that's going to be the main focus. I'm not going to show you too much of the assembly because I've covered this sort of stuff before on many other videos. Good examples would be the TF330 build. I'll stick a link up there to that, and the A3660 PCB, which I fitted an 0402. So you'll have seen those videos previously, and there may be other ones as well. I think I've done a 536 build as well that might not have been uploaded at this point in time. Anyway, so here's the board. You can see a lovely board here designed by Stephen Leary, Mr. Terrible Fire, back in 2016. Boy, how time flies. It seems like 2 minutes ago since Stephen started work on these amazing Amiga accelerators, and yeah, this is one of the early ones. Obviously, he started before that with the 520, I think, which was an 020 board, if memory serves. I'm not sure if I've got one of those, so there may be a build of one of those yet, if I have one somewhere. I'm sure I may well have one. So you can see, let's just pull that socket off. I was just testing that out to make sure it fitted okay. So I've got two Xilinx CPLDs need to go on here, FPU socket, 68030 socket. I think this is 2 meg of RAM. I think each of these is half a meg each, so it was a bit limited this early. One of these accelerators here in terms of the RAM. It's got an SPI port here. Not sure what you can do with that. Maybe connect up a Wi-Fi module or something. I'm not entirely sure. It's got the larger pitch IDE connector there. You've got space obviously here for the 68,000 pin header, you know, to stick into your 68,000 slot there. Voltage regulator, crystal, I think, and then we've got these a few jumper positions, and also the pin positions where you would program it from. I'm just wondering where the JTAG thing is on here. Actually, I can't see it just now. Yeah, it's here. I was going blind. So yeah, it's going to be programmed just the same way the other boards have been done in the past. You could use a Raspberry Pi, but I've got the the JTAG programmer that should work with the Xilinx chips here. So some cheap 68030 sockets, they're getting harder to find. You've seen the FPU socket already. I will fit an FPU on this. RAM, there's different types of RAM you can go with. I've gone with Alliance chips here. There's the Xilinx CPLDs. And then we've got different types of pin strip stuff here. You know, ones for the IDE that have got a square pin, and the rounder ones which will go into the CPU socket there. Some transistors or something there. The 5-pin device, it might not be. It might be a gate of some sort, like an OR gate or something, I'm not sure. 3.3 volt voltage regulators. So I've got 3 different crystals here, gone with a 25 megahertz one, a 33 and a 50. I think that's the majority of the components, and then obviously we've got lots of smaller SMD resistors and caps and things here, mostly caps. I think there are some resistors though, as you can see there. The other thing you might want to consider doing, and I've ordered a couple of these in advance, is a 68,000 relocator. If you're going to fit one of these in an A500, the position where the CPU sits, yeah, I think the board's going to go that way in, but the ROMs and things can get in the way, so like this just moves it away, lifts it away and up a little bit so that you can fit it at the back end of your Amiga. I think it goes that way. Yeah, because the pin 1 marking is there, assuming this is the right way up. Anyway, so I've got 2 of those to build as well. I'll perhaps do those towards the end of this video. So, progress update. I started on the top side of the board. I started with the caps, and then I thought, well, I may as well do some of the other smaller things while I'm here. So I've got the voltage regulator, little resistor pack. These resistor packs are the hardest things to do by far, in my opinion. Those are a close second. Yeah, so these are Schmidt triggers. We've got 2 of those there, another resistor pack, and the crystal. The crystal has got a little bit of the solder on the can there. It's not short to the pin, but I just need to make sure before I test this that we don't have a bridge there. I saw one of Chucky's videos recently, and I think he built a TF 4060, or it might have been a 1260, and it wouldn't start. He had a short when he powered it on, and it just so happened that he managed to do the same sort of thing there, because these are so low profile, and the can is obviously conductive and probably connected to ground. If you short one of the 4 contacts on there to the can, you can end up with a short to ground. So I'm just about to get the capacitors on the underside here. Top side, all the small stuff has been done. An interesting point here, the resistors I fitted here, I ordered 1Ks, and I think that was under advice from Stephen or somebody, but looking at the BOM it says 47K, so I went away and double checked that and found other people had questioned the same thing but gone with 1Ks. So I think the 1K was a later revision, that's all. It perhaps wasn't updated on GitHub, but if you do build a 530, go with 1K resistors. And I vaguely remember that from something 8-Bit Dreams told me when he gave me the proto he had there of the 534, because this has a relationship to the 534. I think Stephen did some sort of what's the word? Some sort of compilation option in the build of the 534, so that it would output the latest version of code there that would work on this, on the 530. And it uses 1K resistors, so yeah, they're very similar. They're totally different layout and everything, probably different CPLDs, but the logic is the same between them, and all of the connectivity and stuff is largely the same. I think this has just got less RAM than the 534. I think the 534's got 4 meg. I think this has got 2. Could be wrong, might find I've got 4, but I vaguely remember this being 2 meg. So I'll show you one or two of these caps. These have took next to no time to get on there. I literally just move them into place, just get a tiny little bit of solder onto the pad and the cap. And I reflow these with hot air, just like I did on the 83660 PCB from Chucky there. And I'll just reflow those with hot air, stand them off my mat here so that I don't melt it. What I would normally do is finish all the others on here and then hit that with the hot air here, but I'll show you that now anyway. We'll just heat this up so it gets to temperature, and it'll either pull itself back into position. If it doesn't, I'll just tap it with the tool here until it bobs a little bit, and then it should be totally centralised. Yeah, you can see it. I'm able to tap it there and it's bobbing around. Let's just do this one down here. There you go, that's centralised now. So I was getting near the end of the caps there, and I was getting a little bit concerned because I hadn't fitted a single 100 nanofarad cap. I think the BOM I've got here, perhaps the one on the GitHub, is not correct. It really wouldn't make much of a difference. You could probably power this with just 10 microfarad caps and it'd probably be okay. But I thought, well, this is not right. So what I've done is, the ones up here are underneath here, the bypass caps for the RAM. So I've fitted 10s up here for those. And I think I've done this on another TF product in the past. The two caps here, they're paralleled up, you know, to supply pins on the 68000 or 68030 processor there. So I removed one and fitted 100 nanofarad there, so it's got a 10 and a 100. And it's all about filtering frequencies, different frequencies here. This is why you typically will have like a 10 and a 100 nanofarad. So the one up here corresponds with that. That should have a 10. Sorry, that should have 100 nanofarad. So I've got 100 nanofarad there. Still got to do under the processor here. I'm going to stick 100 under that, I think. And it was a similar thing down here. Around this area it got a bit confusing. I was like, what pins go where here? I think we've got one on the 3.3 volt rail and a couple on the 5 volt rail from here. So I've put a 10 there because that's paralleled up with the one here. I'm guessing this one is on the 3.3 volt rail. Now if that's the case, on the 3.3 volt here we've got a 10 already. So I'm guessing it's the rail that goes to this, the bypass cap for that. So I'll probably have to swap this for a 10. I'm just going to just check, see if this is on the 3.3 volt rail. If it is, I will change it to a 10. And then I'll stick a 10 here, as I say. And I think we're then done with the caps. So yeah, anyway, you can see the larger ones. That one's going to change to a 10. But you can see the one or two larger ones on here that are 10s. I'm going to leave those two as 10s there. And I think that's all the caps done. And then I'm going to go look at some photos of this board just to work out the orientation of these. So this is a Rev 2 here, by the way. It's not got the ground and VCC rail, you know, you've not got layer, you've not got 4 layers like Stephen introduced in some of his later boards. You can see I've just anchored the corners here. It was a bit fiddly to do that, I have to admit. I don't like dealing with chips this small. They're so small. Yeah, you can see the print. Yeah, so you can see which way that's aligned compared to a photo. I'm guessing the Rev 3 board may have had a dot there to indicate which way around that goes, but I mean, it's not a big deal. You can see how to do it on this video. I doubt anyone's going to go away and build a 530 I'm doing it for nostalgic reasons, really. I've had this sat around and I wanted to build it when it first came out. I just never got round to it because I had so many other repairs on at the time. And obviously, if you were going to go for a terrible fireboard, you're best off going for the 536, really. There are still people out there selling the 536. I would go for the 536. Anyway, we just need to get some flux around that. I'm going to use my old Antex iron, I think. So you can see I've just done that first side. I'll rotate this around and position the camera and just see if I can show you that side. There might be a bent pin there, I'm not sure, because the flux felt like it caught. Just have a bit of a drag along here. We're going to get some bridges, especially near the end here, and we'll just bob in and out. And then down here we're going to need a bit of braid. Can't really see very well for the amount of shininess there there we go. Hopefully you can see. I removed the bridge, and again we'll just bob in and out of these, and then I need to inspect with magnification, make sure we've not got any bridges and stuff. So we're cleaning around that one. Still got the wrist strap on here, by the way. Yeah, that wasn't too bad actually. It is quite a small chip compared to some of the ones that are used on the other boards. They're a bit larger on the other boards. And as you can see, that doesn't look bad actually. There we go, that's both CPLDs on, so you can see the pin 1 notch on this one is towards the right hand side here. It's in this corner here. You can see the print is that way up. That makes sense, there's a hair on that. So obviously I need to clean up with the brush and stuff yet, but there's a hair on there as well, I think. Yeah, both of these are on. So the next thing, we're on the home run now. Just need to get these 4 RAM chips on here and then the sockets and jumpers and stuff. So I'm on to the last chip here. I'm using the crusty Antex, just get just the right amount of solder on there. And then I anchored it in this corner, so I'm just going to re-anchor it over here. Hang on, just solder a few pins over there. Got a bit of a blob of solder there, look. And then we'll just drag over these, hang on, like this. It's easier to do this with magnification. I'm always saying the same things on my video, but when I'm doing it through the viewfinder like this, in fact I'm not even using the viewfinder, I'm looking at it from a distance. It's far harder to do this way. So that bridge there, you could just use braid. I found with this particular tip, a nice easy way I found to do it is slide up the pin and then back down, and you can see it's gone. Bridge is gone. Is it going to work? I don't know. One concern I do have, the resistor packs, the ones I ordered that were recommended, I think, on a bomb that I found on the forum, don't correspond with the ones on the bomb on the GitHub. I think I've got 1K resistor packs, not 10Ks, so that worries me. Obviously we've changed some of the caps. I don't think that's a big problem. I don't think that's going to affect anything very much at all. Those resistors, you know, there were a couple of resistors, weren't they? Again, on the bomb, the 47K, I've put 1Ks, which I believe are correct according to how things were revised, certainly towards the life of the 534, which the firmware is going to be based on. And that's the final thing, have I got the right firmware? The firmware I've got, I'm not sure if it's an earlier firmware. There is one that works with 50 megahertz. Well, I've got 50 megahertz crystal on there at the moment, so we might have to, if this doesn't work, swap the crystal down to 25 just to see if I can get the thing up and running. You know, is it a clock speed thing? And I might have to try and see what other firmware versions are available. So I could, in theory, at this point, go away and program it. Well, test whether I can program it. I'm not going to bother. I'm going to stick all the other stuff on because I've got a high level of confidence we should at least be able to see the CPLDs there and the JTAG chain. You can see the notch on the FPU socket is up here. So if we just get that on, I'll solder that on next, and then we'll get the CPU socket on. So it would be all too easy to just fit another socket and go, look, I got the socket on alright. There's an interesting thing happened to this. I don't know if you saw, when I was soldering the pins there, the solder flowed right down through and up, and it's like, can you see these blobs? There's like large blobs. it was disappearing from the other side of the board. It's like it wasn't soldered on the side where the pad was. It was just flowing down and accumulating on the underside. There were giant blobs. So I desoldered all of the solder from the, I don't know, dozen or so pins I'd done there, and then I used a bit of hot air to free it. You can see these pins have just come through the socket. The socket's not damaged. I'll reassemble that. I could use it again at some point in future. I'm going to go and get a new socket. That was really, really painful. You wouldn't believe it. I think what's happened here is that socket has been left out here. Well, it's been in a bag, but it wasn't sealed for the best part of about 6 months. And one or two of the pins have got a bit of oxidisation on them, which means when you heat, well, what seems to happen is the solder seems to flow down the pin and accumulate on the socket and not actually on the pad. And then you can see what I've done here is I've used one of those extenders to, you know, hold this in place so that it's totally straight. Everything's at the right angle there. So I can now solder a couple of diagonal points to start with. Well, not diagonals, I'm going to do one on each side of each strip there. Press it down nice and flat. Same over here. Same over here. I've got the feeling this isn't going to work. I've spent blooming ages, especially messing with that FPU socket. The CPU socket went straight on, no issues. IDE had a bit of a problem. I had to shave this socket down here. What you really need is a right angle one, but you know, I'm probably not going to fit this into an A500 as it is. I will order a right angled socket, you know, right angle IDC connector there. Yeah, that's pretty straight, I think. So it was too dark to film anything after I finally came to test this yesterday. So here's the board, and there are a few issues with this. Initially it was black screening. I've got a tested 030 here. It's marked 33. It's probably a 25, but it will run at 50, and it's a full one with the MMU. Anyway, I tested that previously. That isn't the issue. I did have the FPU in here. What I understand is when you run these at 50, you kind of need the FPU to kind of add some capacitance there. It's yeah, it's just one of those things. So if you do try and run one of these at 50, make sure you've got an FPU, or you might get some instabilities. So when it was black screening, I spent a bit of time inspecting things and checking things, and I couldn't find any faults or anything. One of the things I did before we programmed it and stuff, I'm not sure I showed that, is just measure between VCC and ground on here to make sure that wasn't shorted, but also the regulator here, make sure that the 3.3 wasn't shorted to ground or VCC, you know, 5 volts either. And then we programmed it up. It was black screening. I looked at some photos of this board because this jumper here, we didn't have anything fitted. Now in a photo I saw there was nothing there, so I thought, well, I don't need anything there. This the board that someone else has built hasn't got anything there. What I didn't realise is that is used to specify whether you use this clock or the motherboard, the 7 megahertz, 7 point whatever megahertz from the Amiga. So yeah, on the board that I saw photos of, people have been soldering the links underneath here. Anyway, we'll get a jumper onto that later. But the other thing I did before that, before I worked that out, was remove the 50 megahertz crystal and fit a 25. I thought, let's just go back down to 25 and see if that solves it. It didn't. That's when I realised the jumper. So we're now in a situation where it does actually boot, but it crashes. It's hanging at the second white screen. You know, it goes, you get like a dark grey, light grey, and then you get white. Well, it goes dark grey, light grey, hang for about 3 or 4 seconds, then it resets, and you get the same pattern. So that would suggest some sort of memory issue, perhaps. But I spent a while last night afterwards. I couldn't do any more work on it. It was too dark. Spent some time looking at the everything to do with this board. There's a hair on there, look, and I think I worked out what it is. I was looking at the bill of materials. When I fitted the resistor arrays, these ones were 1K. It doesn't match with the bill of materials. The bill of materials say 10K. Now, I don't think that's a mistake in terms of ordering. I think I must have read some bill of materials from somewhere else or something. I think someone might have said, oh, just look at the 534 or the 536, it's the same pass. And I think that's how I've ended up with the wrong resistor arrays. And you might think, well, how is that relevant? Well, I'm pretty sure it is. I'll show you. We're going to remove one at a time these resistor arrays and retest. I'll show you the behaviour now, but then we'll retest without each of those resistor arrays and see if it starts to boot. It may well get past the initial problem I've got, and if it does, I mean, I've ordered some of these anyway, 10k ones, that will be the answer. The only other clue I had there was I was looking at photos from when Stephen built one of these initially, and he had ones marked 472, which was 4k7 on these resistor arrays. So I'm guessing that as he was prototyping, he started out around 4k7 and then moved up to 10. So anyway, let me just connect this up and I'll show you what it's doing. So I can plug it into the top of the Gotta Go Fast RAM board here. Obviously when you're testing things like this, it's better to eliminate things in the chain, so I just test just with the CPU card and nothing else. But anyway, it fits quite nicely there, and if I power it on, yeah, this is what I like about 1.3. You can see here, you get this initial colour change thing, whereas you don't get that on 3.1, you just get a black screen. But you can see it hangs there at the lighter grey screen. Let's do that again. So it should go black, then dark grey, hang on, dark grey, light grey. It'll take very little time to get that off, I'm sure. Now there is a chance it won't work at all without it. There you go, it's nearly off, look already. Yeah, there is a chance it won't work without that. I don't think so, actually. I was speaking to Stephen. I thought it was a pull down, I didn't measure it. Stephen said, oh, it's just a pull up. I think he was of the opinion that 2K2 would work, actually. So we'll just make sure none of those pins are shorter than the knot. So it's still not booting. Maybe we do have an issue with this. Other than that, we've still got the other one to remove. Let's just power cycle it again, just to see if we get any further. Nope. In any case, even if it sprang to life now, I will be needing to swap out those resistor packs. Oh, I've got it stuck in at a weird angle, look. Yeah, there we go. Let's just get that in. Let's try that. Yeah, no different there. That is the light grey screen. I'll show you again. Dark grey. Hang on. Dark grey, light grey. Yeah, hanging. Well, that's worrying. I've removed the two resistor arrays there that I think are the only ones that could be relevant, and that's not made a difference. We're still hanging at the second screen there. We haven't got into OVR connected, but that's just for the IDE as far as I understand. So the interesting thing with Logica, we get, well, some coloured flashes and things going on there. It's like it is booting, it is running code. Is it stuck flashing red? I think it is. Might have to go program up Diagrom, I think. I've got an EEPROM here. I might just go and do that, because Diagrom just gives you a little bit more verbose, you know, more information, more detail about what's actually going on as it first powers on. It could be that blooming FPU socket. I'm wondering if when I was soldering the pins there, a couple of bits of solder have joined up two pins, you know, we can have two joined address lines or something like that going on. So that's kind of sort of normal, but then it's that red flashing that I don't get. So about 3 hours later, I've spent ages messing around with this. I cleaned up the pads for the resistor arrays there. I noticed that perhaps when I removed that I lost a pad there, but the trace is right next to it, so I can join that resistor array back on when the new one arrives. I did check, I've got some 10k ones, they're just like 50% too big physically. That's the problem, these things are tiny. The ones I've ordered are 1206. I think 1206 is an entire size dimensions of the footprint would fit. Obviously I'm thinking of 1206 the other way around, like these are 1206 pads here. So it's about the same, actually, the pad size in total, but, you know, for all four pads. Anyway, nevertheless, I removed this. I'm glad I did. Let me just see if I can show you. Which side is it now? Bear in mind, a lot of the solder got removed when I used the dissolve station. Can you see this here, in my thumbers? There's a big blob of solder. It's joining this pad to that one. So that would have been an issue, but it's still not doing anything. It's not booting with Diagrom. I've programmed up a copy of Diagrom, and I cannot get this to boot at all. You'll see I added a jump here so that I could set it to 7 MHz, you know, slow it down. Just the same, if not worse actually. You can't get any text out of it. You get the coloured screens and things like the flashing green, and then the screen just goes black or white and then just sits there. And then it may reset itself and just do the same thing. So it could all just be down to the resistor arrays now. Anyway, I might just, I'm not sure whether to fit this again or not. It's a pain, this socket, it really is. It's supposed to be a high quality one. Right, so while I wait for those other parts, I'm going to make up these two CPU relocators here. So I'm going to just pour all this lot out. There are a couple of crystals here, let me just put the crystals away. So on the A500, the pin 1 is down here at the front of the case. So yeah, the pins need to go on this side here, and the socket needs to go up here for whatever expansion you fit in there. So it's going to go that way up, which means these need to go here. So I'll just trim off the right length here, so it's that point there. That's it, nice clean cut. And we need to do the same with this one here. Yeah, again, a nice clean cut. Sometimes you'll find it fractures on the end there. Anyway, let's get those in there. So this is where another one of these can help you, as we did earlier when we were doing the ones on the CPU card there. Just get this around the right way. So we can now clip this into here carefully. Try not to lose or bend any pins. Is that going in? I'm not sure. Feels a bit stuck up there. Yeah, just needed a bit of gentle persuasion there, but you can see that is now in, so we just need to solder our points. And as we solder each one, we will press it and solder it, just to make sure it's nice and flat and flush. I always think it's quite funny that using something like this to build something like this, do you know what I mean? It's like, it's always worth having one of these around for this very purpose. You could just stick a CPU or something into it, you know, but the beauty with this is you're not heating the chip, are you? You're just heating the thing that's connected to it. It's just connections. If you heated a CPU that's got solder coated pins to do this, you may find you solder the CPU into the socket, which is not what you're trying to achieve, and then just inspect it to make sure it's straight, and it is. And now this is the bit I don't like. I hate getting these apart. We need a tool for this or something. Coming out, there we go. One thing I'll point out where these 4 little diamond pads are here, you can see how easy it would be to bridge these, you know, because we're going to have solder coming up here onto this, the pins of this, and we're right next to the middle of those 2 pins there. So that's one problem with crossing the chips like this. You know, on something like this, those don't happen, do they? The other thing I would point out, this one from Stephen Leary here is superior to this. Now, you could argue that they're doing slightly different things, you know, one's an L shape and one's just shifting it across a little bit. But look how this is laid out. You can see the ground, the solid yellow here is the ground, and it goes in between lots of the traces. You know, you've got like a bunch of 4 there with a little bit of ground just here, but more ground down here. Whereas this, look at this here, these traces, they're just all the way out here with no ground in between, all the way to their destination points from the source. So length of traces like that can pick up noise, especially when they're very close to each other, as these are here. See how close these are? These are incredibly close. So something like this is going to be more flaky with certain CPU cards than something like this. So again, using one socket to help align the other one, it's a bit of a chicken and egg situation, isn't it? You've got to question, how was the original one done? Probably with a processor or something plugged in, or it plugged into a socket. One thing I've tried in the past that can work is use a pair of pliers like that, and then just prise like that. You see that? that is one thing that I have done in the past. If you're not careful, you can damage or mark the board though. You can see that side's out a lot now. This is where, if you're not careful, you will bend the pins. There we go, it's off, it's okay. Just a little bit, don't need a lot. Because what I don't want it to do is flow through to the other side where there's a similar arrangement of the pads here and have too much solder on it. Hang on, I don't think I get any solder on it other than. Yeah, that's it. What I can do is just do some connectivity between the 4 pins that are around there when we're done. I'm going to do that just for my own peace of mind. There we go, that's the soldering all done. So that's them both assembled. I'm just going to clean off the flux now. We'll do it this way first, then I'll toothbrush it. Just testing the first one, and that works fine. And testing the second one. I did measure for shorts, by the way, on those pins I was talking about. There was barely any solder on them, so there was just enough. There you go, and that works fine as well. So as you can see, and here, I've got it up and running. It has been a nightmare, this board. Seriously, it's the most trouble I've had in a long while. I've spent so long messing with the darn thing. So you can see we've got a wire here. I damaged the tracers, obviously removing that RAM the second time, I think. So, and I think there's a fix there as well, a wire there, and there's one on one of the resistor packs there, because the things have been coming off and on, off and on, off and on this board. Let me just turn that down, it's distracting me a little bit. So, in summary, we had lots of problems, didn't we? Initially it wouldn't boot at all. That was because I had completely the wrong RAM chips on. I'll show you the ones I've taken off. They're from a TF534, I think. I must have accidentally put them into the kit for this, and then I've not looked at that kit for 6 to 12 months. Come to build it, I stuck the wrong blooming chips on there. I didn't check the BOM, the building materials there. So when I swapped the RAM, it started booting, but it was totally unreliable with the IDE. It would freeze, and actually for the first, I would say the first 10 minutes, I couldn't even boot from IDE. It wouldn't boot at all. It would stick on the LED would come on for IDE, it would just freeze. So I tried different resistor pack sizes. Now I found if I went to 10k, as I originally had on there, it was worse, and I went down to 1k, it was a little bit better, but you still had to wait about 10 minutes for it to warm up before it would boot at all. I've ended up with 470 ohm resistors in these 2 resistor pack areas here. And at that point it was booting okay, but what would happen then on certain disk activity, the yellow LED for the IDE would just freeze again. So it would boot up, you get to the desktop, then you start a game or went to a folder, it would freeze again. So as I say, it was marginally better with 470 ohm resistors. At that point I thought, what else can I do with this? Really, I've tried everything. I mean, you can see I've got a different adapter on here. I've got the one from Stephen Leary. I had the L-shaped one, which I'll show you after. Those do make a difference. The difference in layout there, whether there's any ground plane on the adapter, makes a huge difference. But also, I don't think you can just about see, I've got the Live 2 memory board below as well, so I'm testing that with that now, but that can make a difference. Now when I had all these problems with the IDE, it was running at 50. I tried lots of different processors here. I've ended up with one without an MMU here. It's pretty hot, that needs a heatsink. It's running at 40 at the moment. It's marked 40, but I don't think it is. It's probably a 25 or a 33 that's been rebadged in China, because that's where it came from. So anyway, I reduced the crystal to 40 instead of 50. I'm not sure what firmware I'm on here. I've gone through a dozen different firmware versions, trying different newer versions, older versions, release candidate versions, beta versions, alpha versions. Not really getting anywhere trying to understand the whole, the IDE problem and it not booting and all that sort of stuff. I've just done so much, I kid you not, I've spent about 3 weeks on and off on this. It's crazy how much time this has consumed. So, we've got a 40 megahertz crystal, it's rock solid, and I'm using the Stephen Leary adapter here. We'll try the L-shaped one in a minute, again it's rock solid with that adapter, and we're using the Live 2 Gotta Go Fast RAM board. So we've got an extra 4 meg at the moment, giving us 6 meg of fast RAM. What else? And I've put the 90 degree, right angle connector on there, just on that a minute ago, just to finish this off. The final thing I need to do is just clean all the bits of flux off and stuff, and I'll give you a look around it, show you the damage that I inflicted upon it as part of the trauma. Yeah, it has been a trauma. This has been a nightmare, this board. But all the time we've been talking, it's been running the June intro demo there. That should loop back round in a sec, I think, unless it's frozen. I hope it hasn't. and it's been rock solid. It's been on for 20 minutes running this game, so I'll perhaps reboot it in a minute. Yeah, it's going around. Look, that's alright. I was just waiting to see if it frozen. It hasn't. I'll reboot it, and in fact I'll show you that now. Switch it off and on. I can't show you the LED because it's underneath it. I can hear it clicking on the floppy drive there, and I can see the IDE LED flashing. Yeah, so what would happen before with the IDE thing, it would sometimes get here and then freeze. Or sometimes, let's say you get here this far, and then you go, right, let's go into a folder, and you go double click, and then it would freeze. Or you might get a little bit further if you're lucky, and then it would freeze in another folder. Whereas now, it is rock solid. Let's load Alien Breed, I think. So you can see the IDE, it's a little bit slow. That's because I've not got MMU libs and stuff, you know, I'm not caching the ROM there and all that sort of stuff. But you've got limited resources. That's one thing you've got to remember with this device, because it was an early prototype. You've only got 2 meg of fast RAM, which sounds like a lot, but when you've got a hard disk like this, I found when you boot this with no additional RAM, just use the 2 meg that comes with the 530 there, you end up with literally nothing remaining at the desktop, about 16K or something, because of the number of drives. Each of the drives you've got on your compact flash card or SD card, you know, you've split it into a number of drives there. Each one of those needs an amount of RAM. So yeah, after booting, let's say you end up with nothing. That's why I added the Gotta Go Faster RAM board. And in fact, I can show you the size there. If I just reduce that and close these windows, that's going to free a bit of memory up as well. Can you see at the top here, we've got just over 4 meg. Yeah, just over 4 meg free. And we've got 6 meg actually, and I can show you that as well if I can find it. Where's it gone now? Sysinfo. Let's do that before we go into a game. If you look at boards, that should show everything there. So at the top we've got 2 meg, that's on the 530. 64K is used there. That's the I don't know what that is that the SPI port or something on the back? But yeah, I think it is. And then you've got the Gotta Go Faster RAM board, which is providing 4 meg. So both of those things are there. We can see that in memory as well, reflected there. So we've got 2 meg of fast 24-bit DMA, 4 meg of fast 24-bit DMA, and 2 meg of chip. Now Live 2's got a new firmware actually that should allow you to use all of the space instead of halving it. What I mean by that is with auto config, what happens is if you've got a clash between 2 cards, i.e. you know the Gotta Go Faster is trying to provide 8 meg and 2 meg is already allocated by the 530, what it does, it halves the amount of RAM and then retries. So instead of 8 it goes to 4 and says, can I use 4? Yeah, I can. You know, that's okay, and then you end up with 6. Does that make sense? It's like it halves it each time until it can fit that RAM into the slot there, the gap if you like. Whereas Live has just done another change. I haven't got that firmware on here now. I might have it towards the back end of this video, and it should allow you to use 6 meg. So we'd end up with 8 meg of fast, and that would be ideal because we now have about 6 point something meg free here. I mean, I'll show you benchmarks and stuff in a minute. In fact, let's just check if the FPU's there, because that's something I've not checked up until this point. I've got a 6882 FPU that should also be running at 40 megahertz. Now the clock speeds here, yeah, they're not reflected correctly. This is due to, I think, not being able to cache the ROM in fast RAM or something, so it looks like it's only running at 7.9 megahertz there. But as you'll see on systest, it runs a lot faster than that. And a FPU clock is showing 25, but it's not 25. It is running at 50. Sorry, 40, not 50. Ah, it's running slow now. What's going on there? Now it is not running fast. Oh, that's weird. Yeah, I rebooted it there, and as you can see, running Sysinfo now, it's showing us up here, performance-wise, which is faster than an A3000-68030 running at 25. That's really good. And you can see up there as well, it says FPU 6882. Comment, smell the rubber. So yeah, excellent, that is working as expected. And I think one of the reasons why this one has been quite difficult, let me click that, is it was a prototype. You've got to remember this is a Rev 2. The Rev 3 was kind of like the release candidate, if you like, which had a few fixes. It may have even had additional layers in there, you know, for ground and your supply rail. I've got no idea. I just know that obviously things improved up the series. You know, you get to the 534 next, which had 4 meg of RAM, and that does run really rock solid at 50 megahertz. And then beyond that, you got the 536, which is the best to go for, and that gives you 64 meg of RAM, dropped the FPU, but again runs a rock solid 50 megahertz. We'll have a look at the 536 in an upcoming video. I've built a couple of those too, but those were far easier to build than this. If you hold down both mouse buttons and kickstart to upwards, you'll get this menu and you can choose boot with no startup sequence. I've got a keyboard connected. As soon as that boots, we'll do a set patch. So that's got us a command line, so I'll do set patch. I can type. I'll change into the work volume into AIBB, AIBB. Just got to mention the environment. I guess there's some sort of variable that's missing there. I'll just choose cancel. And there we go. So into AIBB. Can you see down here? 40 megahertz. CPU clock, 40 megahertz. FPU clock. For the mem test, you can see that's staggeringly fast. Look at that, that's crazy. Compared to an A4040, memory is way quicker, and it's obviously way quicker than an A3025 there. That's amazing stuff. But there's not enough fast RAM, as I say, to well, I'm not really sure what's going on. I'm not really sure what the issue is, because you saw that we got like just over 4 meg. So when you start AIBB, why is it saying some of it's loaded into 16-bit RAM? If we do a floating point math, so I'll do that one first without the FPU enabled kind of thing. I mean, it is enabled, but it's not selected in the test, so it's doing it a different way. It's just using the standard CPU. So you can see there, that's the 3025, so that's proportional, that's about right for an extra 15 megahertz. Yeah, just using the standard CPU. And our value there, what's that coming out at? About 8 or something like that. It's in between 6.8 and 5, might be a bit lower than 8. And if I enable these here and do that again, fmath, you can see it's staggeringly faster because it's using the FPU there. So I don't even know where we are. We're between 21.5 and 43, so what we are, about 30 or something, or 30 something, 32 maybe. So the performance there is staggering. That's obviously faster than 3025, and it's nowhere near an A4040. And if we do the beach ball test, I'll show you the fast one first. Leave that here. Anyway, if I do that again, just watch. That's pretty slow. So that's using the standard CPU. Yeah, so the two wires here I've not talked about. The black one is OVR, the yellow one is INT2, I think. And you can see where they go down there. So without those two wires, it won't work with IDE properly. And then the two jumpers back here are for disabling the cache, I think, and you can disable the data cache and the instruction cache. I think that's what those are for memory serves. The clock selection jumper here doesn't work as far as I understand. It was there as part of the design, but never got properly supported. So, I think if you switch this to the internal position, it perhaps won't boot. This one here, this disable, I am not sure what that does. I'll try it in a minute just to see if maybe that disables it and it runs at clock, standard clock speed. But one of the things I found is when you come to program the two chips on here, if that jumper's on, it only sees one of these chips, I think. So it must be disabling one of them in the chain there. I'm just feeling how warm those are. I have just grounded myself a second ago. Yeah, they're pretty warm. These two are the hottest though, without a doubt. So I think I'm going to get a heat sink on each of those as well. So the 530 in here with the Gotta Go fast RAM board, boots okay, no worries at all. And you can see Frontier running there, so I'll just quit out that. The main thing is you do have some limitations there because of the fast RAM. You only got that 2 meg. Incidentally, whilst that RAM is fast RAM, the 2 meg, it sits in the Zorro 2 area, so it clashes with that 8 meg on the Gotta Go fast RAM board. So you only got 4 there, which gives us 6 So benchmarking the IDE there, you can see 980. Now, I'm not sure what I've done. Let me just show you. If I go back, you'll remember it was like 7.93 MIPS before. I rebuilt this compact flash card and I used perhaps a different version of MMUlib or something. And I might have not even had MMUlib installed previously. Maybe this is the difference here, but can you see that 7557, that's lower. And it's coming up 7.88 MIPS there. So I'm not entirely sure I've got slightly less performance just from some configuration. But yeah, anyway. The main thing is you can see it does run really fast there. You've seen that from the various benchmarks we've done there. IDE, yeah, about a meg per second, which is not bad. You know, if I like open Workbench, you'll see it's pretty quick. It throws the icons up fairly quick there. If I plug a 536 in here on the same motherboard, I can get 4.5 meg with the same compact flash card, which is curious. But the Achilles heel of this upgrade, now you can see there, we've got 1.28 meg roughly. Now that's after caching the ROM in fast RAM. And that is the problem, 1.2 meg free there, fast RAM. So if I load Frontier, you may expect, because we've got you know, 1.2 meg of fast RAM and we've got 2 meg of chip RAM, if we were to load Frontier, you might expect it to run really fast with the 40 MHz processor. But as you will see, it doesn't. It's kind of downclocked now because it's relying on, I think, the chip RAM rather than that fast RAM. There isn't enough. Now, there's a few points there to make. One of the things, when you load something from WHD Load, it uses more RAM than it would do if you're running the game from floppy. So if we played this game from floppy now, we wouldn't have an issue, I don't think. Although, I'm not sure whether it would be loaded into fast RAM. It may do. It depends on how the game's coded, perhaps, I don't know. So you can see here it's a little bit faster than it is on a 500 or 500 plus, but not by what you would expect. Look at that. That's a little bit jerky, and it's more evident here. To watch this. Yeah, so straight away I'm like, that's not running full speed. And as we get further into this here, it's more evident. Yeah, look at that. It's like missing lots of frames. Look how jerky that is there. You know, it's like stuttering. I'm stuttering. See that? That is not running at 40 MHz. We'll boot without a startup sequence. Now, because perhaps the version of the firmware I'm using, the memory doesn't get added on the second reboot. So what I mean by that is when you go into that boot menu there, I think there's 2 reboots. You've had the first reboot, you go into the boot menu, you say boot without a startup sequence, and then it reboots itself. The memory is not added in, and you can see that here. If I just do Avail, see how we've got 0 fast mem? It doesn't add it in. Now that could be the version of the firmware I'm using. Perhaps I'm not using the latest one, or perhaps the latest one doesn't do the auto config correctly. I honestly don't know. Maybe it's a consequence of running at 40 MHz instead of 25 or something that this was originally designed to run at. But in any case, what we can do is just add it manually. So I'll do the obvious stuff like set patch first, and then we'll add the memory, add mem, and you can get add mem from Aminet. It's just a single executable download in a an archive, and you need to put the address, the start address, and it's 20,000, 2 5 zeros, and its end address, which is 3 and 5 Fs. There we go. So that should have added 2 meg, and if I now do Avail, yeah, there we go. We've got 2 meg of fast RAM, and then we can do CPU. We'll do cache, burst, and fast RAM. So this is exactly the same as the way it's configured a minute ago, where you saw it boot to the desktop and run through WHD Load. But you'll notice, because we haven't got the overhead of the actual user interface up there, watch what happens if we navigate into the relevant place. If we go to DF1, oh, hang on a minute, not DF1, DH1. If we go into DH1, there's all our folders. So we'll just navigate into Frontier. There's the Frontier files on the slave, and if we just do WHD load frontier.slave, that will launch, and just watch the difference here now. It's noticeable, highly noticeable. Yeah, I'm not sure if I showed you that little bit before, but yeah, it's much more fluid, that. as soon as we get to the part where I did show you before, you should see a noticeable difference. Yeah, look at that. That's vastly different. It's on par almost, you know, when you're running this on a 536 or something at 50 MHz, which is bound to be. It's most of the way there in terms of clock speed, isn't it? And if you watch this bit as it descends now, look at that. So you've got loads of frames that were being skipped there. There's no stuttering and juddering and all that. So we're back at the desktop there, and that fast RAM thing I was on about, the Zorro auto config, you can actually simulate that here. You can see we've got the memory there. If I just did a control Amiga, let it reboot, when it gets back to the desktop you click somewhere and it shows a 0 of the mem. So it's like the auto config at the moment with the firmware I'm using only seems to kick in on the very first boot. Reboots subsequent to that, it doesn't add it in. You can use AddMem to add it back in, but anyway. So that's interesting. If you do know what that is, maybe Stephen might point out it is the firmware. Please let me know in the comments down below. But yeah, the Achilles heel of this is the fact it only has 2 meg of fast RAM. You know, the 32-bit fast RAM, that is. You can add more RAM. Now, I've tested this with Live2 Gotta Go Fast RAM board, and I can add an additional 4 meg. That does work, but due to the fact we've only got this little bit of fast RAM left after caching the ROM, you end up running slow, yeah, so you don't gain any of the speed benefits of having this processor. So you need to think carefully if you're going to go with something like this, how you configure it and stuff, and you might need to tweak settings and things to, you know, to minimise the install so that you've got more of that fast RAM available. Obviously if you boot from floppy, the whole lot's available. It's one of those, so it is what it is. It was an evolutionary step in the Terrible Fire series here. It was nice that it brought this RAM in, but 2 meg was just not enough to do much, you know, with, really. It wasn't really a meaningful enough amount. It really needed 4 or 8, you know, and that's where the 534 came in. That brought 4 meg fast RAM, and you know what, that was a really nice amount to add, because you could load most games in WHD load and it would be running at full speed. But some of those games that, and there aren't that many, some that use more than 4 meg, you would start to have you know, slowdown issues and things. But yeah, the 534 was a much more logical step. You know, it's a much more logical card to go for. I put this in sort of same category as the 520. It was a stepping stone. It's proved, you know, some of the things that needed to be done in order to get to a better solution, i.e. the 534, the 536, and the cards that followed. And I've tested this a number of different ways around. I'm not sure if I've shown them all within this video because it's been you know, filmed at various different points in time. But you can see me using the Terrible Fire relocator here that just kind of shifts it up and over that way. But of course, look where the IDE comes out on this particular, you know, setup I have here. It's not practical. You couldn't fit the keyboard over there if you're going to put this in a cased A500, so you really would need one of the ones that moves it over here, yeah? It moves it 90 degrees, but even then, I think it shifts it that way, so the board would be just a bit further up there. You know, you'd have a gap down here where it would be cut off and it'd be further up here, but then the IDE would be right around here, so then you need to use a cable. Now, one of the things I haven't shown, I had a cable. The cable's about that long, and with certain compact flash cards I was getting checksum errors. As soon as you boot, it would come up with the desktop checksum error, block or whatever, and it happened on a couple of different cards, and I was like, oh my god, has it corrupted my cards? And I kept rewriting my cards, yeah, testing again, same thing, and I would test on other accelerators or on the PC and they would work fine. So I'm like, well, it's not corrupting the cards. And then it dawned on me, I thought, I wonder if it's because this is not buffered and it's the length of the cable, even though it was just a short cable that long. So again, later cards in the series, as you'll see, have buffering, and that's where that kind of problem goes away. So if you did relocate this way around and have the IDE over here, you need to make sure you've got a really super short cable just to flip over, or don't have this type of connector here. Have the one where it's facing upwards, like I originally started to fit on here, I think, but it gets very close to this socket here. You might need to trim some of that socket off to try and you know, accommodate it. So again, echoing a point in the 520 video, I think this is perhaps better off suited to fitting in an A2000. You know, just to give you a little bit of a boost in one of your A2000s if you've not got you know, something more powerful in there. But You could do better with a 536 or a Pi Storm or something like that, but the Pi Storm at this point in time, actually I haven't got to the video yet, it's in its infancy, so there's a fundamental problem with it that means you wouldn't want to stick a Pi Storm in there just now. It's nice for playing around with, and when it gets perfected, I am sure it will be an amazing little board, you know, little card. Just like the Buffy, I think the Buffy might have a bit of an easier time because it's got Stephen helping work, you know, alongside that to get maximum compatibility and stuff with it. But the Pi Storm, yeah, it's got an issue I'll talk about in the Pi Storm video. The other point I may have already mentioned is power. Obviously, you know, this adapter here, it needs 5 volts and ground. It doesn't need the ground, actually, it just needs 5 volts. So, you know, for me, this adapter is a bit of a pain. And the way the IDE was implemented on here, it needs the INT2 and OVR connections, just like the IDE 68K board we covered in a previous video as well. But as Stephen worked through the Terrible Fire series, you start to see a change where the INT2 and OVR is no longer needed. He was able to cut out the reliance on those two signals and you know, sort of keep tally on them, or keep track of them, if you like, in the CPLD via other means, you know, i.e. some address decoding. I've ended up with a wire here and a tiny little wire there, can you see it, to fix the you know, the board there, because I'd removed the RAM a few times and with the wrong RAM. Incidentally, I think I sent the old chips after I cleaned them up to Sparks UK, because he was building a 534 and that's what those RAM chips were for. Now they hadn't got hot, that's the thing. As I tested with the wrong RAM, one of the things I kept doing was just checking temperature of things, and it was stone cold. So I didn't think they would have taken any damage, but he, straight away, when he built that board, couldn't get the RAM working, so I think it's the RAM. I've said, look, just order some of the RAM. Yeah, so a little bit more in-depth to build, because it's got the two CPLDs, finer pitch versus the one on the 520, and obviously you've got extra things. You've got the IDE connector, you've got the FPU socket, you need to fit an FPU. Obviously it's 030 instead of an 020, and you can see that's the one I went with, the markage, if it's genuine. It's an EC 030 RP40B. I think it is a 40 because it runs quite happy at 40, they run at 15. It doesn't get too hot even at 40, it just gets warm. Could be a 33, I think a lot of these are RP33s that have been rebadged, but those will set you back about £7, £8, £9 on eBay. They're going to start getting short in numbers, I think, because of these cards. You know, so many of them are being sold, and of course prices are going up. And here's the other one that I built. You can see this is missing the two CPLDs at the moment. I ordered the complete wrong one. I actually ordered the right part number, but you can get these little chips here in like different pin configurations. So I think the ones I ordered were 100 pin, so they're slightly larger and obviously got more pins. And I think it needs 64 pins or 72 pins, I forget. I think it's 64 actually. So I'm going to need to order two CPLDs for that when I get paid. But there's a difference between these. I just want to quickly show you. These are different revisions. You can see I did the same thing here, just doubling up these caps just for consistency. It doesn't really need them. I do crazy things sometimes. I am just that way inclined. You can see also it's a bit dirty. I'm going to get this in the ultrasonic cleaner. So you'll see this board in the ultrasonic cleaner video as well. And I'll give this one an ultrasonic clean while I'm there as well. You can see it came out fairly clean on both sides, but there's perhaps just the odd mark and a bit of flux, etc., and certainly underneath the ICs and things that will benefit from going in the ultrasonic cleaner. This is a Rev 3, so if you buy one of these boards now, you're going to get the Rev 3, and there's a difference. Can you see there's a little capacitor or something there that doesn't feature here, but also there are some other differences as well. I think it mostly relates to the underside. Can you see we've got an extra cap down there that doesn't feature on here, and there's an extra one up here as well, look. So I think that was for the purposes of putting 100 nanofarad ones. You know, you got 100 nanofarad, that is. Yeah, so that might be the only change there. There's also an extra pin on the SPI port there. I'm not sure what that's all about, because on that one there, you can see there isn't. So that's weird. I will stick the SPI pin header on this one as well. I'll do that in a minute. Well, yet again, Farnell failed to disappoint. Look at the size of this box. This is ridiculous. It's absolutely huge. Yeah? What's inside it? One single CPLD. A single CPLD in a box that size. That is just ridiculous. So I'm guessing somewhere in here there's going to be one IC. Can't even see it. Oh, there it is. Look at that. That's ridiculous. So let's try and get this open. You know, I really hate this cling film. It's like the sort of stuff you put around your plates when you sit in the fridge. It's like, it really annoys me when they put cling film around this stuff. And it can't be ESD safe at all. Alright, you know, I'm not the most ESD safe person generally, but if I was shipping something out to somebody, I wouldn't be putting it in cling film. Oh, maybe they are. Yeah, so they sent me 2. I need to check, did I actually order 2? I was sure I ordered more than 2, but anyway, so get one of those out. A little bit on there. The fact it's come in a chip carrier like that makes me think it's a genuine one, actually. They've probably ordered it from Farnell or DigiKey, hence why I haven't been able to get one. I'm going to take the CPU and FPU out of this first, just because these are heat sinked on here with some thermal adhesive. What's that out? So I had to pull the heatsink off there to get it out with the extractor. There we go. And we'll just switch it on for a minute or 2. So with the black one here, the R3, I'm getting nowhere. Let me just switch it on. I'll just show you the logic probe is working. We've got 5 volts and ground here. That's ground. That's 5 volts. So the board is powered. Now I asked Stephen what component goes here, because there's a single component not fitted on here, and I wondered if that was related. Now I did a connectivity test, and it goes to the Schmitt trigger over here, so it's clock related. If I actually probe it, that pin, you can see it's just high. We've got no clock. And it goes to the centre pin on the Schmitt trigger there, I think. Hang on. Oh, it's floating. That's interesting. Now, if I put the jumper over into the other position that uses the onboard motherboard clock, you know, the normal 7.19 megahertz or whatever it is, and I think if we probe that now, yeah, look, we've got pulse in there now. So it would appear this oscillator's not working, actually. That seems to be the problem. So I'll remove the oscillator, we'll try another oscillator, we'll inspect the connectivity around there before I actually solder the new one on. So the plot thickens. This is one of those rabbit hole problems that just gets deeper and deeper, and you just don't seem to get anywhere with it. I've gone through 3 crystals here. Both of those were previously used on the board to test things. So just to rule it out, I thought let's just go with a brand new one. So I got a brand new one on there, and I measured the clock, 0 volts. Now I measured the voltage, because you should get like the average, you know, the mean of the signal if it's a clock, because bear in mind it's an LV, you know, it's powered by 3.3 volts this, so my logic probe, if I probe it, I may see a low, but there is actually 0 volts there, absolutely 0 volts. So then I took it a stage further and thought, well, if there's 0 volts there, let's actually just test to ground, and I'll show you what I've discovered. The clock, it seems to be shorted to ground. This is just bizarre, and I noticed it by measuring these 2 pins here. I knew that one of these was ground, and we got a direct short there. So then I went from the pin headers over here, 5 volts is on the inside, ground's on the outside, so we got ground there, that's correct, and ground there, that's not correct, and it goes to this pin here, on the pin header. So, something around here is shorting out the crystal output to ground, but I don't get what is doing it. Is it these crystals that are failing with terribly little heat? I don't know. You know, you install it with just a little bit of too much heat and it dies. I didn't use hot air to install it, so I don't know, but I'm now in a situation where I've now got to pull that crystal off in order to work out where the short is. I wonder if Stephen changed this on RA3 and the pin out is the other way around or something. I don't know, it can't be, because it does go to that pin there, so I don't know, it's bizarre this. Part of me is happy actually, because it is, well, it does seem to be that the clock is short to ground, because those 2 pads now are still short. So the question is how? I'm just going to inspect just to make sure they aren't actually joined physically on the board in some way. But I now need to follow it. Now it goes to this Schmitt trigger here, doesn't it? Like, no, that comes from the centre pin. So it can't be the Schmitt trigger. It's got to be something around there, maybe. Or there's perhaps a cap or a pull-up or something somewhere that's shorted. I don't know, this is going to take me a while to diagnose this now. It's like being on the magic roundabout this, I tell you. The next problem is there are additional grounds that shouldn't be grounds, like data bus connections, for example. Those are grounded as well, just watch. These 2 are joined. I haven't worked out where that clock is joined yet. I can't work it out. But these are data bit connections here, you know, data bus. Look, we've got short there. That was a short, I've cleaned it up. That was a short, I've cleaned it up. So I'm going to go around and check ground for every single... Oh, we've got another one there. That might be ground, but I'm not sure. yeah, I'm going to go around and check every single pin, because what's happening is the ground pour, you know, the ground area around these and the gap in between, the gap is so small that you can end up with a tiny, and the solder mask, can you see it's gold here, gold, 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 gold. The solder mask is not covered properly, which means it's very easy to get a bridge to ground. So I would hazard a guess that some of the pins around here are causing me the problem. Quite how this is, might be the ground pour around there actually, around that might be the problem with that. That might be where that's grounded. Anyway, I'll report back when I've tested all the rounds here and cleaned off the little particles of solder that are joining up. That did take a serious amount of messing around. I had to use my probe here and scratch all the way around that pad several times before I could isolate these two from each other. So it's still joined there, as you can see, as it should be, but they're not joined to each other. And as I say, the ground, the one up here, that was a pain in the butt. I had to desolder, remove all the solder from it, and then again scratch all around it. It was joined from manufacture. So anyway, I've gone around to ground and I've tested every single one of these. The only thing we've got connected there is a ground. UDS was joined up to ground. One of the address lines was joined up to ground, and as I say, about 4 or so, maybe 5 data bits were joined to ground. So those are the sorts of problems. If you've got a terrible fireboard that you start to build and you couldn't get it working, you didn't get anywhere with it, you need to inspect and check ground there. You know, measure from a known ground and test connectivity on every single through-hole connection. Yeah, we've got to hope the same issue is not applying to some of the SMD connections here, because you know what, could be a no hope of this. And I don't think it's all about the board design here. I think it's the fab. It's whoever you get to manufacture it. The quality varies between manufacturer to manufacturer. Anyway, let's get a crystal on. Let's see if there's any signs of life now. 100th time lucky. I did just check that clock to make sure it wasn't shorted to ground still, and it isn't. So what I'd expect now is reset. And when I say reset, I mean a reset noticeable here, because previously you'd power it on. Oh, there you go, it's doing it now. And it's working. Who Ray? I've spent ages messing around with that, like 2 days messing around with it. Anyway, I'm grateful it seems to be working. And the question is, does the RAM work? And we need to test the ID, obviously. But yeah, we got 2 mega fast there, look, 2 mega chip. Ah, very pleased. A successful conclusion. And just like with the 520, we went through a few different crystals here. I tried various speeds to work out what was most stable. I tried a few different firmwares. I can't remember, I'm kicking myself, can't remember what firmware I ended up landing on. And as I pointed out earlier, I did some crazy stuff for the caps here, doubled them up, just to try and aid with stability. But you know what, it doesn't need that. I think the original bomb was like 1 microfarads in all of these positions, and it would have been fine. But I doubled up with 1s and 100 nanofarads just in the key places underneath the main chips here. So finally I got there in the end. Yeah, we had problems with both boards here. This one I fitted the wrong RAM to, so yeah, some damage around there. And incidentally, I'll just cover the resistor eraser stuff. I ended up with 470s. Yeah, 470 ohm on this one here. The one up here is just for jumpers, so it's not that essential, but these ones are like for some of the control signals and things, so they're a bit more critical. The bomb says 10k, I went with 470 ohms, and that works fine. On this one I didn't have any 470, so I went with 1k, and again it works fine. What Stephen said was 2k2, so you could go anywhere really up to 2k2. 470 is a bit low, but you know what, these are both rock solid, stable. Everything else on them is identical in terms of component specs and stuff. We've got the same RAM here. This one is the Rev 3. And I guess it's worth mentioning the difference with the Rev 3 there on the reset. You know, with auto config on this one, if you do, hold both mouse buttons down and you disable the startup script, you get no RAM. That doesn't happen with this one. And likewise, you can boot to the desktop on this and you get your RAM. If you do Control, Amiga, it resets. You've got no RAM. That doesn't happen on the Rev 3, so there might be a wire mod or something you could do, but it's kind of been lost to the ether in time kind of thing, because Stephen originally would have covered it on his channel, but unfortunately, when people cheesed him off, he got rid of his channel. I don't think he was that bothered about losing his videos, but it just means we lost that bit of information. Stephen might remember, I don't know, there might be a wire mod you can do on that one to get the auto config working with a soft reset, but it might be firmware that fixed it. But nevertheless, the Rev 3 doesn't suffer from that. You can see these went through the ultrasonic cleaner. They look good as new. It looks absolutely immaculate. So yeah, very, very pleased with those. So special thanks to Stephen Leary. These have been really fun to work on again. I got the second board, by the way, because I was having problems with the first one. By the time I damaged some pads of Pyrophore, maybe I need another board, and that was why I ordered this, but then we ended up getting that one working. I do hope you've enjoyed the video. If you would like to support the channel, please see the Ko-fi and Patreon links down below. Every donation of $1 makes a huge difference to the continuation of this channel. Without donations from Ko-fi and Patreon, things like this I wouldn't be able to do, so I'm very much indebted to all the people that support me. Thanks for watching. I'll catch you in the next video.